Did you know that the total surface of your lungs, all alveoli combined, equals the size of a tennis court? Let's play. Before you start wondering why I did not put away these groceries from my desk, they are actual props that I will use in this video to explain the anatomy and the physiology of the pulmonary system. Before we dive into the airways, we need to define the difference between respiration and ventilation. Respiration is the process of gas exchange. Ventilation is the process of airflow. Respiration therefore involves the actual metabolism of the cells, the consumption of oxygen, and the exchange of O2 and CO2 between the tissues, the blood, and the environment. The internal part of the respiration is about the gas exchange at the cellular level between the body cells and the blood. For example, in your quadriceps when you're running. The external respiration is about the exchange of gases between the lungs and the blood. Ventilation is an essential process in order for the respiration to occur, but ventilation as such is just about the movement of air in and out of the lungs. Obviously, the main function is to form a pathway for the air. So air with oxygen can move into the lungs during inspiration, and excess CO2 can move out of the lungs during expiration. Right here you can see that the air passes the trachea first before it can go deeper into the lungs through all these small branches formed by these smaller airways. Ultimately, the air needs to reach the alveoli in order for the diffusion to occur between the air inside the alveoli and the blood that passes by through these very small capillaries. So just imagine that these oranges represent the alveoli and the net represents the extensive network of capillaries. You can see that if the network is good and extensive and the blood flow and the fresh airflow actually match, gas exchange is perfect. If you imagine the lungs to be very special balloons, it's even more impressive to realize how they operate. There's no muscle or ligament attached to them, as you might think. Instead, the lungs are placed inside two very thin membranes, and thanks to a negative pressure between them and some lubricant, the lungs remain glued to the chest wall. And this will allow the chest and the diaphragm to determine the volume inside the lungs. If we use some high school physics, we can explain that an increase in volume would lead to a decrease in pressure in a closed system. As the airways are not closed in relation to the environment, air will automatically flow in due to this pressure difference. If you want to expire, you can do the opposite with the volume of your chest. You can reduce the volume of your chest, which will increase the pressure inside the lungs. So air wants to flow out of the lungs in order to make the pressure equal to the pressure outside of your body. And that was expiration. Have you ever seen an example of this negative pressure failing between those two pulmonary membranes? That is called a pneumothorax, a collapsed lung. And as this balloon can show you, when the air can escape out of the balloon, the elastic recoil of the material will cause the balloon to collapse. In a real lung, if the negative pressure between the membranes is gone, there's no force left to keep them open, and the elastic recoil will make sure they collapse. And similar to a balloon or one of these TheraBands, the lungs also have a sort of a natural compliance, the ability to stretch and respond to a certain amount of force applied to them. If the lung compliance is higher, it requires a smaller pressure difference to achieve a certain change in lung volume. Before I can make clear what this dishwashing detergent has to do with the compliance of your lungs, we need to really look into the cells that form the inside of the alveoli. In plain English, the type 1 cells form the surface for the actual gas exchange, whereas the type 2 cells are relevant for managing the compliance of the lungs. Inside the alveoli, there's a thin layer of water. This layer is very relevant for the normal diffusion process, but the disadvantage of this water layer is that it has surface tension, and that will make it harder for one alveolus to get stretched compared to a dry alveolus. If you have ever jumped from a high cliff into the ocean, you might have experienced surface tension under your feet at the moment that you reach the water surface. it hurts like crazy. And that is because the water lines up due to the electrical charge of the molecules, and that creates surface tension that even insects can walk on. And on YouTube, you can find great experiments on. Now, the body has assigned an important role to these type 2 cells as they secrete surfactant as a soap to break this surface tension. This will make sure the lungs get stretched more easily, which means that their compliance therefore increases. If you take a deeper breath, type 2 cells will get stretched more and as a result secrete more surfactant, which will make the next stretch even easier. One of the main reasons why taking a deep breath every now and then is so helpful. I would like to encourage you to keep playing with balloons or with the TheraBands or even with this detergent to maximize the understanding of the function of your precious lungs. I will see you in the next video.